Hi, everybody. This is Dr. Nigro with a Chemistry Notes screencast. This screencast is going to cover material from our first unit, Introduction to Chemistry, and specifically look at the topics of measurements, uncertainty in measurements, the metric system, and then conversions within the metric system. All right, so we're going to be using a guided notes worksheet that we'll be filling in as we go. If you miss class and you need to complete this portion of the notes packet, please have that handy so you can follow along. All right, so first up is measurements, and we're going to start by defining what we mean by that word measurement. It seems pretty self-explanatory, right there in the word. A measurement is a measured amount. Now, a measurement has to have two parts for it to be considered a measurement. The first one, we need some sort of number. All right, it cannot be a measurement if we don't have some sort of numerical value associated with it. And in addition, that number needs to be followed by some unit. All right, so if you just have a number, that's not a measurement. All right, if you just have a unit, that's not a measurement. You need to have the two together. All right, the purpose of the unit is to indicate what you are measuring. All right. So there are all kinds of things that we can measure. All right. We could measure someone's height, right? We could measure the time it takes to do something. We could measure the mass of an object. So anything that we use a tool and then gain a numerical value with a unit is going to be considered a measurement. All right. Now, we're going to take measurements most often in class and we're going to manipulate them using math. So we can multiply, we can divide them, all kinds of stuff. When you do that to a measurement, you have to consider the unit. All right. So units can be multiplied and divided just like the numbers, which can lead to us canceling units just like we would any number. All right, now that becomes really important when you look at whether you're setting up your problems correctly. All right. All right, so we're going to do an example. We've got a square, or I guess it's technically a rectangle. All right, it's got a measurement of 6 centimeters wide and 5 centimeters high. So if I want to determine the area of that square, I'm going to need to utilize the formula for area. So area is equal to width times height, or side one times side two, depending on what class you were in. And for us, that's going to be 6 centimeters times 5 centimeters. All right, so I'm going to multiply the 6 and the 5, and I'm going to get 30. The question is, what about the unit? All right, so I'm really going to end up with a centimeter times a centimeter. All right, and anytime you multiply something by itself, that's the same thing as squaring it. So this is equal to centimeters squared. So that's why when we calculate the area of something, we get units that look like this, 30 centimeters squared. Now, if we had just written 30, that would be incorrect because there's no unit, so we don't know what the measurement is of. All right, if we had just included the unit, that would also be incorrect because we don't have the numerical value. We need both of those to explain what we have measured. All right, now, all measurements are going to have a degree of uncertainty. All right, well, what causes this uncertainty? Well, there's two factors really. All right, there's the accuracy of the measuring tool you are using. All right, we'll talk about that a little bit more in a minute, but generally speaking, you want to use tools that are as accurate as possible. You want to take as much of the guesswork out of that measurement as you can. All right, the second problem is one we really can't do much about, but it's the accuracy of the person doing that measuring. All right, now, many of you don't know me or don't see me every day, but I wear glasses. And if I took my glasses off one day and tried to do a measurement, I might not be as accurate as I might be with my glasses on. So there's also a degree of uncertainty due to the person making the measurement. Now, there's not much we can do about that, all right, because a person is a person and hopefully they at least measure the same way each time, all right, but we can focus on the tool that we use. We can make sure that we choose the appropriate tool for the job. All right, so some examples of some measuring tools that we can use are things like rulers or meter sticks, depending on what we're trying to measure. Whoops. All right, we're also going to use volume measurers or graduated cylinders. Whoops, I'm running out of room. And then we also are going to use things to measure math like balances. And we could use triple beam balances, but we tend to utilize electronic balances. All right, there are other things that we might use in the lab sporadically depending on the experiment, but these are going to be our main tools: rulers, meter sticks, graduated cylinders for volume, and then balances for mass. All right, now each of these tools is going to have what's called a scale. All right, and the scale of a measuring tool is determined by a series of lines that are laid down at equal intervals on the surface of that tool. All right, these lines have two different names. Most often they're called graduations. Now, that's not the same as you graduating from high school, but it's a different use of that word. Or sometimes people will call these tick marks, particularly when they are on a graph. All right, so if we look at these two graduated cylinders, A and B, let's find one of these tick marks or graduations. So you can see one right here. All right, this would be another example. All right, so they are markings on that cylinder or that tool that are spaced equally as you move down the tool. All right, the scale of your particular tool is equal to the value of the smallest line or graduation on your tool. Your measurement is reliable to this decimal place. All right. You are allowed to estimate one additional decimal place past what you know. So basically, you use the scale to determine the known number and its position in terms of the decimal point. And then you are allowed to estimate one more digit past that point. All right. So what does this look like in terms of our graduated cylinders? All right. So what we're going to do is define what the graduation means in terms of numerical value. Then we're going to define where we can be in terms of the estimated digit and then write down the measurement for each of these cylinders. All right. Just as a reminder, all right, we always measure at what's called the meniscus. When we deal with volume, it is the bottom of that curve. All right, we won't have that problem when we measure something like length, but when you measure volume, we have capillary action. We have to keep that in mind. All right, so let's start with what the graduations mean on cylinder A. So we can see we have a 10 and then a 20, and then it's separated into ones. So this would be 11, this would be 12, this would be 13, 14, 15, then 16, 17, 18, and 19. So the graduations, it changes by 1 milliliter as you move from graduation to graduation. All right, so I can know how much I have in there at least to the 1 milliliter position. But then I'm going to estimate one position after. So I'm going to estimate the 10th position for this graduated cylinder. So that's my guesstimate part. All right, so for this one, if I look where the bottom of the meniscus is, where I've got my dotted line, I can see I'm past 20, and then I have 21, 22, 23. So that graduation where the meniscus is looks like it's at 24. And then for me, it looks like it's right on that line. So then I would estimate that it's 24.0. And that would have a unit of milliliters. Now, maybe you see it slightly differently and you say, well, I think it's at 23.9 milliliters. Or maybe someone else looks at it and says they think it's at 24.1 milliliters. And so you can see that this is where the uncertainty of our measurements come into play. All right, so now let's move over to the graduations on cylinder B. All right, so we have a 1 here and a 2 here and then a 3. All right, so we're not having graduations of 1 milliliter. This time it's zero point 0.1, then 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and zero point 0.9. All right, so these graduations represent a tenth of a milliliter or zero point 0.1. So that means we're going to be able to know accurately to that position, to the 10th position. So our estimated digit will be the 100th position or 0.01. All right, so I go look at my graduated cylinder. Whoops, that's not it. And I'm going to look at that meniscus. All right, and to me, it's clearly past 2, but less than 3. So if I count 2.1, 0.2, 0.3, 0.4, 0.5, 0.6, so it is definitely above zero point 0.6. So now is the estimated part. It looks like it's halfway between those two graduations. So I'll probably go with 5 here and list my measurement as 2.65. But again, maybe you go with it being a little lower and you put 2.64 or a little higher at 2.66. The key is that we are all in the same general ballpark with that measurement. All right. Now, how do I choose what instrument to use? All right. Well, when choosing a measurement tool, you want to choose one that is larger than your amount measured, but close to the amount. All right. To get the most accuracy for that measurement, then I want to make sure I'm not choosing a tool that's too big for what I'm trying to measure or too small for what I'm trying to measure. I want one that is bigger, but I want it to be as close as possible. All right. So what does that mean? All right. So if I want to measure 8.5 milliliters of a liquid, and I can choose between a 10 milliliter, a 50 milliliter, or 100 milliliter graduated cylinder, I'm going to choose that 10 milliliter cylinder because it's greater than my 8.5 volume, but not too much. So I'm going to get the most accuracy by choosing the tool that is closest to what I'm trying to measure. All right. If instead I wanted to measure 75 milliliters of a liquid, then instead of 10 or 50, I need to go with the 100 milliliter graduated cylinder. The 10 would be too small, the 50 would be too small, so the 100 is going to be my choice here. All right. If I took this 75.5 and tried to use a much larger graduated cylinder, such as a 1000 milliliter graduated cylinder, this is going to be very uncertain in my measurement. I'm much better off taking that volume and putting into a 100 milliliter graduated cylinder. Okay, so because of the length of the screencast, I think what I'm going to do is save the metric system and the conversion calculations for a second screencast. So if you need information about the metric system, the units within the metric system, and then the prefixes of the metric system, please find my screencast that deals with those two topics. All right. Thank you.